So rational functions have two types of discontinuities. They have either holes or they have vertical asymptotes. In this particular set of examples, we're not deciphering between these. We're calling them points of discontinuity. PODs for short. Points of discontinuity is an x value for which the function is undefined. It's a particular point of discontinuity. Points of discontinuity happen when the denominator is equal to 0. Denominators can never be equal to 0. So our job is to figure out, is there any possible x value that I could put into this function that would cause a point of discontinuity? So the deal with rational functions have a domain of all real numbers every time, except that x can't be a few points, PODs. So our job is to figure out what the domain is essentially here with these problems. Every time, all real numbers except a few values. And those values, the process is very simple. You set the denominator equal to 0 and solve. Any value you get is called a point of discontinuity. So any x value that results, you just say x can't be that value. So in this particular problem, all that build up to say, you take x minus 9, the denominator, and set it equal to 0. X minus 9 is not allowed to be equal to 0, so we're going to figure out what it could be. In fact, you can give yourself a little can't be 0. So then you solve, and you get add 9 to both sides, and we get x can't be 9. So the answer to the question is, what value is this expression undefined? 9, because x can't be 9. So let's try this for another expression. Again, we don't worry about the top right now. We don't care. We're just looking for points of discontinuity. So all we do is set the denominator equal to 0 and solve. Or say it can't be 0 and solve, whichever way you like it. So 2x plus 10, set it equal to 0 and solve. And then that looks like subtracting 10 from both sides. And you get 2x equals negative 10. Then you divide both sides by 2 and get x equals negative 5. Now, x equals negative 5 is actually saying that x can't be negative 5. Negative 5 is the value for which this function is not defined. This is my point of discontinuity. And later we'll decipher whether it was a hole or a vertical asymptote for another lesson. All right, this time we're going to up the ante a little bit. Same process to figure out a point of discontinuity. We're not concerned with the top just yet because that's only to matter, or it only matters for what type of discontinuity. All we do is set the bottom equal to 0 and solve. So the bottom can never be 0, which is why we're doing it. So x squared minus 81 equals 0 and solve. Now the idea here is that we could either factor this using difference of squares, or we could use the square root method. I'm going to use the square root method by adding 81 to both sides. And that's going to give me x squared equals 81. And then the inverse operation of the square, to get rid of that, is use square root. Don't forget, we have to have plus or minus every time we do the square root method. So it's going to be x equals plus or minus 9. Now, what that's really saying is x can't be plus or minus 9. If x is at positive or negative 9, the bottom would be 0, and that's impossible. So those are my two undefined moments, the only two undefined moments of this function. The domain over the whole thing would be all real numbers, comma, x can't be plus or minus 9. D for domain. But again, the answer to the question was just plus or minus 9. So anytime we have plus or minus 9, it's really just 9 as one answer and negative 9 as the other answer. All right. Now we're really going next level. Same question. When is this undefined? To answer the question, we're supposed to set the bottom equal to 0 and solve because the bottom can't be 0. Well, now we have a quadratic trinomial. And the way through this problem to solve would be to factor and solve. So I would jump in and do the magic x. And I put a 2 on top and a negative 3 on the bottom because it's a times c and b on the bottom. And I decide what multiplies to be 2 and adds to be 3. And of course, that's 2 and 1. Both of them have to be negative. to get the -3 to work out properly. Now, I don't have to do the grouping on this one because there's a 1 in front, so I just jump right into the factored form, and I get x minus 2 and x minus 1. Set each of those equal to 0. X minus 2 equals 0. X minus 1 equals 0. X equals 2 and x equals 1 are my points of discontinuity because x cannot be those two values. X can't be 2 and x can't be 1 are my two values that cause this function to be undefined. 2 and 1.